Section 9.5 Magnetic Forces on Moving Charges. You've learned that magnetism is caused by intrinsic electron spin and how electrons essentially line up. So if a charged particle gets near those lined up electrons, it's going to experience a force. The magnetic field will push it. But in this case, instead of pushing it in a similar direction like you would see from the electric force, it instead experiences a deflecting force. It's moved in the opposite direction or an opposite direction. So for example, if it's traveling forward, the magnetic field would cause it to turn left. This concept of deflecting electrons using a magnetic field is what was used in old television sets. This is why old tube televisions have that huge back. They have in the back a ray that pushes electrons onto a screen and that is controlled by a magnetic field generated inside of the television. That's why they're also so very hard to repair. This is also how the Earth's magnetic field, which is generated by the iron atoms inside of the Earth's core, this is how the Earth's magnetic field protects us from harmful cosmic rays. It deflects them away from the Earth. When those strong cosmic rays hit the atmosphere near the North and South poles, you get auroras. Similarly, a magnet will affect a wire if that wire has a current in it. So if you place a wire with a current inside of a magnet or a magnetic field, then the entire wire will be deflected. So for example, here we have a horseshoe magnet, and if you put a wire in between and the current was traveling in this direction, the force in the wire would be upwards. It would push the wire up. If the current is traveling in the opposite direction, it pushes the wire down. So the direction of the force is dependent upon the direction of movement of the electrons. And in fact, the only way that the charged particle experiences this force is if it's moving. Charged particles at rest are not affected by magnetic forces or magnetic fields, only if they're moving. And so we know that magnetic fields and electric fields and charged particles are all related. Magnets come about from regions of atoms who have aligned charged particles. Electric fields come about from charged particles in space. So they all have something in common. And we'll discuss more about this in a later section. So we can use magnets to perform tasks or to measure things. We can measure properties of electricity using magnetic properties. We can use an object known as a galvanometer, which is used to detect current by basically registering changes of magnetic properties in the wire. In this case, the galvanometer can be used to measure current or voltage. If it's used to measure current, we call it an ammeter. And if it's used to measure voltage, we call it a voltmeter. Many of these things you see now are digital. They're called digital multimeters, and you can choose which type of meter you want it to be. And it measures more than just current and voltage. Generally, it measures a lot of other electrical properties as well. You can also build a motor using a magnet and a current in a wire. If you place a wire inside of a magnet and run a current through it, that wire, if it's in a loop, will experience forces in opposite directions, and it will cause the wire to rotate. And what you get is a moving loop inside of that magnet. And it will continue to move until the current runs out or it's removed from the magnetic field.